Welcome everybody to tonight's novice meeting. It's the August novice meeting of the Houston Astronomical Society. And my name is Chris Morissette. I'm your HAS novice chairman. And I think we have a really great presentation tonight by a really great speaker, the Galileo Museum by Bill Spizzirri. And I'm just going to give you a short introduction about the presentation and about Bill. Bill's going to discuss Galileo's life through his experience and exposure to the Galileo Museum in Florence, Italy. He's going to cover Galileo's astronomy, his astrophysics, science, and inventions. And I've never been to the museum myself, but my understanding is it is really provides a unique insight into the history of of Renaissance science, which is a very pivotal time in all of science, but in particular of astronomy. Bill is a retired mainframe computer software engineer from Chicago, and he has been studying astronomy for 70 years and has belonged to several astronomy clubs over that period of time, and has served in various offices of various clubs. His favorite astronomy activity is teaching astronomy to children and the public, and I can certainly vouch for that. Bill and I we volunteered at Space Center Houston here a couple of weeks ago, and Bill came in with a wagon full of all kinds of neat stuff. And I think, unfortunately, I wasn't able to see it, but he put on a really good presentation for the people down there. So with that, I'm going to stop my talking and I'm going to stop my share and I'm going to turn it over to Bill. So Bill, if you would, please go ahead and share your screen. Okay, so real good. So before you kick off, Bill, let me just make a couple of comments. If you would, please make sure you're on mute. And if you have questions, please put those in the chat. And then at the end of Bill's presentation, I'll come back through and we'll go through the questions. So if you could do that, that would be fantastic. And with that, Bill, I'll turn the floor over to you.
Okay, thank you very much, Chris, and thanks for everybody who's joining. It's a privilege and a pleasure to talk to you about this topic, which is kind of near and dear to me. So, Galileo Museum is in Florence, Italy, and why do they make a museum for one person? That person's got to be kind of an amazing person, and that's certainly true for Galileo, as you can see on the right. Famous physicist Stephen Hawking said Galileo probably bears more of the responsibility of the birth of modern science than anybody else. That's quite a statement, especially coming from Hawking. And then, of course, Einstein said Galileo is the father of modern science. So when you get accolades like that, they build a museum for you. And of course, he is considered, a favorite son of Florence. So that's where the museum is. Okay. I'm hoping you see my next screen.
Yes, correct.
Okay, fine. So I was in Italy because I have a whole bunch of family in Calabria. That's the southern region, like the toe of the boot of Italy. And there's my family. And my wife on the right there. You can tell it's my family because they're eating and they're drinking their own wine. They made 200 liters of their wine every year. This is the life in Italy. The view on the right is the view out their back door. They live in this tiny mountain town, which if you wanted to hide from, the tax collectors or something, this would be a good place to do it. It's absolutely beautiful, but it's in the middle of no place up in the mountains in Italy. So that's where we were. And I see in the lower right-hand corner there, this is the pictures I took in 2011, but they're still there. Anyway, so can you see my cursor moving in the ocean now?
Yes.
Okay.
We can see it.
So down here in the toe of the boot is where I was with my family. And then Florence, you have to take trains or whatever to go all the way up here to northwestern Italy to Florence. And that's where the museum is. Okay. And you see a picture of the museum on the right. I'll tell you, when I saw that sign there and I knew where I was, I got darn excited. And when I see this picture now, I remembered that excitement. Anyway, so the Galileo Museum. So I'm going to begin by telling you about Galileo. Please forgive me for this screen. Do not even try to read it. I'm not even going to try to read it. I'm just going to touch on some of the stuff that's highlighted there. Okay, his is a summary of his life. In 1564, he's born in Pisa. Okay, he moves to Florence. 1581, his father wanted him to study medicine, so he went to the university in Pisa to study medicine. He didn't like it, as you might have been able to figure out. He changed his major to math and science, and that's what he did for the rest of his life. In 1588, he was teaching perspective art. That's a certain art form that's sort of mathematical in nature. And so he was a great artist too. Um, in 1589, he becomes the chair of the mathematics department in the Pisa University. So he was a very accomplished mathematician. Later on, he's teaching geometry, mechanics, astronomy, and he studies and teaches the fundamentals of science, physics, and the physics of motion and astronomy. So he's getting into science and art in a big way. In 1597, he corresponded with Johannes Kepler, a famous astronomer from Northern Europe. We give you a separate presentation on his work. The big deal, 1609 in green there, is when Galileo used his telescope to observe the moon, Venus, Jupiter, and Jupiter's moons. Now, he did not invent the telescope, but he was the first guy. People in Northern Europe invented the telescope, but Galileo was the first guy to come up with the idea of pointing the telescope towards the objects in the night sky. And he was fascinated by what he saw, and he improved and improved and improved the telescope until he got one that was 30 power, which back then was big was a powerful telescope back then. He was improving them. And so he made his discoveries. We'll go into that stuff. And in 1610, he also observed Saturn and the Milky Way. In 1612, the planet Neptune, very briefly, and sunspots. We'll talk about that later. And in 1613, he began his defense of heliocentrism. That means the sun is the center of the solar system. Whereas what most people were saying, professing, and thinking back then is that the Earth was the center, not just of the solar system, but of everything, the entire universe. And he said, no, 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 no. Now, he's not the first one to come up with the idea. Nicholas Copernicus, a Polish astronomer, is the first one to come up with it. But Nicholas Copernicus was scared to death to tell anybody about it. So he didn't publish until after his death, if you can imagine. And Galileo did it. Okay. He began his defense of heliocentrism. And so in a few years, the powers that be, which is Pope, Rome, Catholicism in Rome, called him to Rome to say, hey, you shouldn't be talking about heliocentrism. And they had a long conversation with him. I wasn't privy to what they said, but they told him to stop, basically. Stop saying this stuff because it's heretical in the view of the church. Okay? He didn't stop. In 1623, he published a manifesto on how science should be conducted, the right way to do science. We'll talk about that more later. 1632, he published a dialogue concerning the two chief world systems. In other words, he's trying to give a fair attempt at both sides to give their side of the story. One side saying the Earth is the center of everything, and the other side saying heliocentrism, that the sun is the center of everything. Unfortunately, the way he wrote, I won't say unfortunately, but the way he wrote it is that the guy who was in his book, the dialogue, professing geocentrism, that the Earth was the center of everything, came across as a real dummy guy, an idiot. And that was not lost on everybody who read it. They could tell that by publishing this, Galileo was saying, that's not true. Heliocentrism is true. Guess what? Right away, he's called back to Rome again on the Inquisition, and he is threatened with torture, literally. I won't go into the details on that. And he is put under arrest for the rest of his life. Now, he's not tortured or killed because he had to quite literally had about like a 2-page confession that he had to read while kneeling down in front of the Inquisition, maybe in front of the Pope, I'm not sure, and read this. By the way, if you can find it on the internet, read it. It's very interesting reading. And he kneels down. He reads this confession, saying he's not going to believe this. He's wrong. He's not going to talk about it. He's not going to publish it. He's not going to teach it. Okay. And then and the legend goes that as he's getting up from kneeling, he mutters under his voice the Italian words "e pur si muove," which in English means "and still it moves." In other words, you can arrest me, you can torture me, you can do whatever you want with me, okay? But the earth is still moving around the sun. And what you do to me doesn't matter. I used to have a bumper sticker that had that in Italian. I don't know where that is. Anyway, so he was very serious. They were serious, but he was serious too. In 1638, he went blind, possibly because he was studying the sun and sunspots. I don't know. I haven't heard why. He dies in 1642, and he's buried in a small grave at the age of 78. But then later, his remains are moved to Florence. I will show you the tomb in Florence. And then 350 years later, in 1992, the Catholic Church, Rome, the Pope, officially states Galileo should not have been condemned like he was. So they kind of looked at the evidence and agreed that matters of faith come from the church, but when it comes to astrophysics, maybe leave it up to the scientists. And so they officially kind of said they were sorry, I guess. Okay, sorry. That's his whole life there. Here's a summary of his scientific contributions. Observational astronomy. I already mentioned he observed the moon, Jupiter, Jupiter's moons, the Milky Way, Venus sunspots. Astrophysics, the heliocentric system. The sun is the center of the solar system. Physics. He studied the laws of moving bodies. In other words, the earth is spinning, the earth is going around the sun, but we don't feel it because we are in the same constant velocity as the earth. He studied lots of other stuff about moving bodies too. We'll go into a little bit of that. That's in his museum. And as I mentioned before, the scientific method. He said, do you want to learn correctly from science? Do you want to gain knowledge from science? You got to do experiments, make observations, and do the math. Then you can say you know something. Okay. And he had inventions, a thermometer, the 30 power telescope. Okay. So he had many science contributions. By the way, I'm going to try to go through this quick, but if you want to go into a lot of detail about the life of Galileo, there's a DVD. If you see on the bottom there in blue, learn25.com. It's 5 hours of 12 lectures about Galileo, extremely detailed, narrated by Guy Consolmagno, if I'm saying his name correctly. He was the chief Vatican astronomer at the Vatican Observatory in Rome, who I had the pleasure of meeting on several occasions. And so this is an extremely informative DVD if you want to get a lot of detail. And talk about detail, there's a book called On the Shoulder of Giants, published in 2002. It's 1,200 pages, but only 236 are for Galileo. It covers those 5 scientists you see there: Copernicus, Galileo, Newton, Einstein, and Kepler. Okay, so 236 pages about Galileo. There's a lot of math in there, a lot of geometry. So fasten your seatbelt. But if you want to get into details, it's available on Amazon. Okay, so here's the tomb of Galileo in Florence. In the lower right-hand corner, you see the church of Santa Croce. Let me tell you something. In Italy, they know how to make churches, okay? Absolutely beautiful, stunning basilica. And there's his tomb. You see him in the middle, and these ladies adorning the side of the tomb. This has got to be at least 12 feet tall, something like that. It's absolutely beautiful, in keeping with his status in Florence. Okay. Here's some close-up pictures. You see him with a telescope and a globe, of course. Underneath his picture, what you see there is, shall we say, a chart that shows Jupiter and the 4 moons that he discovered. Okay. And then in the center of the picture, there's a close-up of the Jupiter from the left, and it's got that strange symbol on it. You may or may not know that all the planets in our solar system have a symbol that goes with them. Mars, Venus, Mercury, even Earth, all the planets. And that symbol you see there is the symbol for Jupiter. What is that? Well, in Greek, Jupiter is Zeus, the king of the gods, because, it's the biggest planet, right? And, well, we know that. They didn't know that, but they said it was the biggest planet. And so that symbol that looks like a kind of a number two, that's a Z in the Greek alphabet. And then that vertical line behind the number two means it's a capital letter, which means it's the first letter of the name Zeus. So that's officially the symbol of Jupiter. Okay, enough of that. So in the museum, you got to guess, they got a lot of telescopes in the museum. Okay, when it's a museum for Galileo, a lot of telescopes. The two on the left are actually telescopes that he used. Okay, and if you look on the bottom, you'll see that oval ivory frame. I'll explain that to you in a little while. So they actually have Galileo's telescopes. On the right, unfortunately, you see me next to a bunch of telescopes. My wife kept telling me, now stand by the telescopes and stuff like that. So that's why I'm in the picture. And look at all those telescopes. Those are all telescopes from Galileo's time, the 1600s. Okay. Some of them are his, most of them were not, but it shows you the kind of telescopes that they made in the 1600s. Again, the two on the left are ones that Galileo actually used. And they're there at the museum. Here's a close up of one of his telescopes. They're made of wood and paper. Okay. Nothing like a telescope nowadays. And, that lens you see there is probably an inch or less. So this was one of his smaller telescopes, very crude by what we know of as a telescope. Here's another one. Obviously, on the right, you can see it's nicely decorated artistically with gold, but again, a very small lens. Again, it's made of probably wood and paper. And I mean, not much of a telescope, right? But he changed the world of astronomy with these very small instruments. Okay. Now, back to that thing in the ivory frame. As it says there, it's Galileo's objective lens. That means the lens on the front of the telescope, inch and a half. It's the one he used for his observations in 1609 and 1610, which was his most important historic astronomical observations. On the bottom of the lens, if you can see my cursor here, it's cracked, but that happened after he made his observations. And on the right, you can see the ivory frame, very fancy decorative ivory that they keep this lens. And obviously, astronomically speaking, this is the national treasure, an international treasure, Galileo's telescope lens. So there's more telescopes, and I'm showing you a lot of telescopes here, but this isn't all of them. Look at the one above me there. It's got to be 12 feet long, made out of wood. This is not from Galileo. These are just lots of old telescopes that they have there in the museum. The one on the right-hand picture, if you can see my cursor, is mounted on a big circle. And that's so that telescope can point directly north. It can be then turned to go directly straight up or directly south. It can't move to the left or the right. It can't move east or west. It can only move on that line that goes from due north to straight up the zenith, which is straight up through the North Star, and then straight south. Because that line from south to the zenith to the north is called the meridian. And what many astronomers wanted to do, especially back then, is to watch when an object, which is going to move from east to west, as everything does in the sky, or most things, when does it cross the meridian? And then they would time that very precisely. And then they would see when it crossed the meridian, the timing the next night, the next month, the next year, so they could accurately measure the orbits of the stuff that they see in the sky, okay, and how long they take to move. So they're trying to measure the sky with these kinds of telescopes. And then on the right, more telescopes of various designs, okay. Not too much I can say about them. They got a lot of them there. So I mentioned before, he observed sunspots. Okay. Before he did this, people thought that sunspots Well, first of all, they thought the sun was perfect, so it couldn't possibly have a spot on it. And they thought that, but people saw the spots, and they shouldn't have been looking at the sun, but they did. And they assumed that the spots that they saw were in our atmosphere because the sun is perfect, couldn't have spots. Galileo didn't believe that. So what he did is he constructed this contraption here. So it's a room, the windows in the room are completely blocked with dark curtains, except for a small hole that he points at this telescope through the small hole in the curtain. Okay. And then he has this box here in which the telescope is attached, and it can be moved so that it focuses properly on this screen that you see on the right. And this is how he observes the sun and sunspots. Now, this entire room, this device was called a camera, and that's because the Italian word for room is camera, and that's where we get our word for camera because of his design for observing like this. Okay, what's a camera? It's a box with the lens and something that you focus the image on. Okay, your eyepiece or film or whatever. I think maybe he was the first guy to do this, but his whole room was a camera, and he would project the screen, project the sun on that screen. And so by doing so, he could see the sunspots. The picture on the left is from a video they have at the museum. That is, by the way, I'm not supposed to be taking pictures of their videos, but so don't tell anybody I did that, okay? But I thought this was important stuff that I wanted to show people. So when he projects the sun on the screen, he can see all the sunspots. Then he uses a pen. They didn't have pencils back then, I'm pretty sure. He uses a pen to outline the sunspots and fill them in to make drawings like the ones you see on the left, on the right. So on the 20, this is in 1612, as it says, on the 24th, he drew the sunspots that he saw. And on the next day, the 25th, again, and the 26th and the 27th. And it was obvious that they changed a little bit from day to day, and they moved in these pictures from the left to the right. Okay. And he also saw that if you waited enough days, they'd come back around on the other side. So he was absolutely convinced that one, they were on the sun, and two, they were kind of a quasi permanent feature on the sun because they came around X days later after they went around the sun. And so this showed that the sun rotated also. All right. So this is how he observed sunspots. Is this contribute to him going blind later? I don't know, but anyway, that's what he did. Here's another one of his genius inventions. So on the left, again, another video that I took a picture of. You see his telescope, and you see this wooden ring with a wooden stick sticking out to the side. And if you look at the picture on the right, you'll show what he sees when he looks through his telescope. So here he's looking through, let's say he's looking at the planet Jupiter or the moon or something like that. And he he eyeballs the image in his telescope. He sees approximately how big it is, and then he looks at the that stick, which has a ruled scale on it, and in centimeters, or I don't know what he had back then in the 1600s. So he would say, okay, the object right now is, let's say, a third of a centimeter or something like that, based on how he looked at the scale. And then this way he could observe objects later on, next day, a month later, a year later, to see if the size has changed. And then he would know, is the Earth getting closer to it or further from it? Or is the object moving toward the Earth or something like that? And then he could document the size of the object in his telescope instead of just trying to remember. So this is an invention called a micrometer, and I think it's a little piece of genius. Another one of Galileo's geniuses ideas. Oh, by the way, on the lower bottom, you can see a picture of the micrometer a little better in the middle. Here's another one of his inventions, a so-called geometric military compass that they have there, which he invented in 1597. In 1597, he invented an analog computer. Okay. It has three parts, this long part on the left, the long part on the right, and then the curved scale in the middle, and then a part on the right that moves up and down along the long straight piece. And then, of course, you see the weight hanging. Okay. so there's scales etched on all of these parts, and there's a total of 11 scales on the front and back of all three parts, 11 different scales to make all kinds of measurements. Okay, he documents 16 different calculations that you can do with this device. The military wanted it. I'm not sure what the military wanted to do with it. Maybe to estimate distance to the object, or to, if they're going to fire a cannon, how high, what elevation should they point their cannon at to go a certain distance? I don't know, but they paid him a lot of money to do it. And since it's a computer, he published the manual that goes with this device, which I worked with computers for 40 years. And I had a lot of IBM manuals, a lot of computer manuals, stacks of them. And maybe he wrote the first computer manual because he published it in his home. And the reason he did that, he says, he thought maybe somebody could copy his device, but they're not going to have a easy time using a copy of the device if they don't have his manual that goes along with it. So he says, okay, you want the manual? Then you got to buy the advice from me because I'm the only guy who has the manual. So they bought the device with him because they get it from him. He gives them a copy of the manual so that they know how to use it. And so maybe he made the first computer manual ever. I don't know. Anyway, that's there in the museum. Now, this to me, everybody knows Galileo for his telescopic observations, but to me, this might be his greatest genius. It's called the Jovilob. So he's observing Jupiter and Jupiter's moons, and he's trying to quantify what he sees, their orbits, their speeds, and everything. So he makes this, he designs this device, okay, the Jovilob, and it's used to calculate and display the orbital periods of Jupiter's moons. I'm going to show you a couple things about it and show you a quick video which really describes it in detail. So here's Jupiter. Okay, each of these vertical lines is one half is a grid, and each line is separated by a half of Jupiter's radius. So anything around Jupiter could be measured, right? And then these four circles, 1, 2, 3, 4, are the orbits of Jupiter's moons. Here is the sun, and then here is the Earth, and here is the Earth's orbit. Okay, and this is all tables about the numbers about the orbits, the locations of the moons. All right, so he had to. He had to take into consideration the fact that the Jupiter goes around the sun, Earth goes around the sun, and the uh, and so they're constantly changing their positions. So if he wants to be very accurate about the positions of the moons, he has to take that into consideration. Okay. So I'm going to show you the video now. I hope you can hear this. Turn up your volume if you can. It's a 3-minute video, and it explains the Jovilob.
In January 1610, while exploring the heavens with his telescope, Galileo discovered 4 small star-like objects around Jupiter, having soon concluded that these were the planet's satellites or moons. He sought to establish their orbits and periods. The velocities of orbital motion decrease from the innermost to the outermost moon. All 4 display almost the same brightness. It was difficult, therefore, to work out which was which and calculate how long they took to complete their orbits around the planet. To determine the positions of the moons without having to perform complex calculations each time, Galileo developed a diagram, a sort of analog calculator, called the Jovilob. The design shows Jupiter and the orbits of the 4 moons to scale. The orbits are placed in a grid of parallel vertical lines spaced at intervals equal to the radius of Jupiter. While making his telescopic observations, Galileo would estimate the apparent distance of a moon from a planet in units equal to Jupiter's radius. The intersection between the vertical line corresponding to this distance and the circle representing the moon's orbit gave its position instantly. By means of a thread, one could read the value on the marked scale drawn in the margin. However, the moon's observed positions vary with the relative positions of Jupiter and the Earth, because of their revolutions around the Sun. For example, the timing of a moon's passage in front of Jupiter, as seen from the Earth, differs from the timing of the same phenomenon if it were observed from the Sun. The time difference depends on the Earth-Jupiter-Sun angle, known as the annual parallax. To cancel this continuously variable effect, Galileo recorded the motion of the moons relative not to the Earth, but to the Sun. To avoid complicated calculations, he developed a second diagram consisting of a representation, to scale, of the orbits of Jupiter and the Earth around the Sun. Jupiter is assumed to be immobile at the moment of the observation. The diagram features a graduated scale giving the Earth's position relative to Jupiter. The parallax value could be read instantly on another graduated scale. The two diagrams were combined into a single instrument known as the Jovilave. Jupiter's position at the moment of observation was computed by means of a rotating disk. A moving pointer fixed with an arm to the instrument's plate served to determine the Earth's position at that same moment. The arm thus represents the Earth-Jupiter link, that is, the observer's continually changing line of sight. The parallax value for any position of the Earth relative to Jupiter could be read directly on a scale on the upper rim of the instrument.
Okay, that to me was a work of genius on the part of Galileo. We don't know for sure that he constructed this one, but it was made in the 1600s, the Jovilab, the actual device you saw. But we don't know if he actually constructed it himself. But he designed it, that's for sure. Okay, here's another thing. In the museum, when they moved him, I told her they buried him once, and then they changed his burial location to Florence. Some people removed two of his finger bones. I don't know why they did that, but that was in 1737 when they moved him to Florence, and then they disappeared in 1905. I don't know how somebody misplaced them, I suppose, and they were found in an auction in 2009. So on the left, you see his thumb. On the right, in the larger jar there, you see his right middle finger. No comment on that. And one of his teeth. I was stunned when I saw that. It's not the kind of thing that you usually see in a museum. And so I just said, may he rest in pieces. Anyway, okay, so here, again, lots of telescopes in the museum. Look at this thing. This lens was made in 1690, shortly after Galileo, and mounted in 1767. It's used for experiments where they would concentrate the light of the sun to burn diamonds to figure out that they were made out of carbon. Okay, Michael Faraday, who did all kind of electrical discoveries, repeated those experiments, and the lens and the tube were also used. This is a strange-looking telescope to observe the absorption bands of stellar spectra. In other words, the spectrum of stars, to find out what the material the stars are made out of. So another thing that I mentioned before that Galileo studied was the physics of motion, of falling bodies. And he developed this device you see here, an inclined plane with these little switches you see in the center, the switch that rings a bell. So he would put a ball bearing at the top of the inclined plane and roll it down, and then he would hear the bell ring as it went down. Now, each bell was placed at a location, so it was 1 second later as the ball went down. So it was always a second between the bells, but the distance it covered during that 1 second was not the same for each bell. During the first unit of time, it covered 1 unit of distance. In the second unit of time, another second, same unit of time, he covered 4 units of distance, 2 times 2. And in the third unit, he covered 9 units of distance, 3 times 3. So he showed that the distance traveled in a for a falling object is proportional to the square of the time. So uh, he was discovering the mathematics of falling objects and the laws of motion. That was just one of the things that he did. Um, Here's a video. I'm going to skip this. We'll play it very quickly. It just shows you the device. By the way, this was a copy that was made in the 1800s. He designed it, but so you can see how the ball bearing flicks and rings a bell, ding, 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 and of course it's accelerating as he moved it. So it's a way for him to study the acceleration of falling bodies. Okay, here's another thing he invented. He called it a thermoscope. He wanted to show that there's a relationship between air pressure and temperature. So stay with me on this. I know it's a strange looking thing. At the top, you see a glass ball. You hold your hands on it for a while to warm the air inside the ball. Maybe 5 minutes or so, you warm the air. And then step 2 is you remove their hands. Then you lower the tube coming from the ball through that cork into the flask at the bottom, which is half filled with water. So the tube is now into the water. And then in step 4, you watch, and what will happen is the water in the bowl will rise up the tube. Why? Because the air pressure in the tube is decreasing. Why? Because the air in the bulb that was warm before is now cooler. And so as it cools, its pressure decreases and it sucks the water up the tube. Okay. And he showed there then that there is a direct connection between air pressure and temperature. So he was a scientist doing all kinds of interesting things. So there's so much in the museum, I can't even get close to showing you everything. These are pictures. A lot of them are things that he used and he designed. Some of them are not, but some of them are astronomy and some are not. Some of them are geometry. But there's so many. I just want to show you some of the things that are in the museum. Look at all these telescopes, microscopes, watches. That thing in the lower right-hand corner, I don't even know what it is. If you do, let me know. In the upper left-hand corner is the so-called Santucci Armillary Sphere, made in 1593. And if you can tell, look at it, you can see that Earth is in the center. Back in those days, Earth was the center of everything, geocentrism, not heliocentrism. And this is supposed to demonstrate or depict all the objects in the universe orbiting the Earth. Okay, and this is just the kind of stuff that they have in the museum. There's so much of it. This is just a tiny bit of it. And now, one last thing. So the museum's in Florence, and Galileo spent a lot of his time there. But he comes up with his telescope, and he thinks it's really great, and he figures he could sell his telescope. So to sell it, you got to go where there is money. And in Venice, which is several miles away from Florence, on the coast of Italy, there's lots of very rich merchants. So he took his telescope there to show it to the rich guys. Hopefully, they're going to buy it. So on the left-hand side, you see a view of Venice. You can see that it's on the ocean in the distance there. And in the middle, you see the clock tower in St. Mark's Plaza in the center of Venice. And so he went up to those blackened windows that you see at the top of the tower and took his telescope, and he had all the rich guys, and back in them days there was no elevator. They all had to walk up to the top of the tower, and he showed what they could see with the telescope. Now, why would these rich merchants care about a telescope? Because, as you can see, they can see the ocean from up there. And when you talk about merchants back in those days, everything was done with ocean-going vessels, okay, to getting goods and selling goods to other nations, other cities. So it was important for the rich merchants in Venice to be able to see which ships are coming towards the docks in Venice, which ships are leaving, whose ships do they belong to, what are they carrying, things like that. And so he thought he could convince them that this was an important thing for them to have for their business. And the picture on the right, Galileo is the one with the red beard, okay? And you see the rich guy dressed in fur looking through the telescope. So those windows that he's showing the telescope through are those same windows at the top of the tower. Now, when I went to Venice and took these pictures, um, I went up to the top of the tower. I don't remember if there was an elevator or not. I think I had to walk. Anyway, so I got kind of goosebumps when I was standing there where Galileo was standing, showing his telescope to the rich guys. And I really enjoyed that. And so, well, and I suggest you could do the same if you make it to Venice. To me, it was an historical moment for me. So after that, I went to the bottom of the tower, and surprise, surprise, there's a gift shop there. And they have all manner of Pinocchio was very popular. Pinocchio stuff and all kinds of Italian souvenirs, you name it, Venice stuff, Italian stuff. Okay. And then as I was paying at the cash register, I looked on the back wall and there was a tiny little screen. That's a picture I took. And I saw the word Galileo on it. And it was in Italian. I didn't know what it meant. But I later translated it to English. And what it says is this, as you see at the bottom of my screen here: Galileo Galilei, with his telescope from here, August 21, 1609, widened the horizons of man in the fourth centenary. The fourth centenary refers to the fact that in 1609, that was the 400th year from when Venice was became a city. Okay. And it had been a city for 400 years. And then Galileo came here and widened the horizons of man there. And it's a tiny little screen. I'll bet you it's 8 inches across on the back wall behind the cash register. And very few people see it. But to me, wow, it was very exciting to see that. And I thought it was a nice thing for them to have there. Thank you very much for your time. That's what I wanted to show you. I'm sorry I had to talk so fast. I didn't want to keep you here too long. There's the museum. There's His Honor Galileo. And I'm available for questions.
Hey, Bill, that was great. Really appreciate that. I wanted that we do have a couple of questions in the chat. And since I'm the moderator, I'm going to start with mine. And then I got a couple of comments too, but what was his aha moment regarding his support for heliocentrism? Was it his observations of the moons of Jupiter, or was there something else?
Yes. Well, first of all, the moons of Jupiter said, sorry, everything doesn't go around the Earth. Thank you very much. Okay. Then he also saw Venus. And maybe you know this, maybe you don't, but Venus orbits the sun, you know that. And because it orbits the sun, it shows phases. When you just see it as a bright star in the sky, you can't see the phases. You just know that some days it's brighter and some days it's less bright. And sometimes you can see it and sometimes you can't. You can't see it when it's behind the sun, right?
Right.
And so because it has phases, if you do your geometry, that means it's going around the sun too. So he's determined that the moons are going around Jupiter, Jupiter is going around the sun, Venus is going around the sun. He kind of put, if you ask for an aha moment, I'm thinking that's it, especially Venus, when you see the phases, because Jupiter is where it is, we can't, without an extremely powerful telescope, see the phases of Jupiter, okay? But you can definitely see the phases of Venus. So let's face it, I think we've learned he's a smart cookie. All right. And he put two and two together and said, Earth isn't the middle of the universe.
Gotcha. So your slides on his work in defining the laws of motion or demonstrating the laws of motion. This is before Newton, correct? I mean,
you are correct, sir. Yes.
And if memory serves me right, one of the Apollo missions, I was a kid.
Yes.
They had one of the astronauts had a feather and a hammer and dropped them, and they both hit the ground at the same time. I think was that Galileo?
No, he was not on the moon.
No. I know
that. Just kidding.
I know that, but I mean, was that his postulation?
Yes. The legend is that he went to the leaning tower of Pisa.
Right.
You know, if you're on a tower that's not leaning and you drop stuff, it might hit the side of the tower. But fortunately, he had a tower that was leaning even back then. So he went up to, and we don't know if this is true, But this is the story, that he went up there and he had a small cannonball and a big cannonball, and he dropped them both. Now, the current thinking back in those days was obvious. The big one is heavier. It's going to fall faster and hit the ground first. And he dropped them both at the same time, and they hit the ground at the same time. So he said, that's just one of his ways of expressing the laws of motion. That
Yeah.
it was just a fact that's the way things move, and he's trying to refine our ideas of the laws of objects. Okay, and so, because since he did that, and it was true or not, it was legendary when Alan Shepard, I believe, was the astronaut who did it.
I think you're right.
And I remember that video, and anybody who wants to see it, I'm sure it's on YouTube or someplace. It's gorgeous because he's on the moon in his spacesuit. And he got a feather. He took a feather to the moon, which most people don't do. And he's got an ordinary hammer, and he drops them. And the feather and the hammer drive together. Oh my God! You want to just jump up and scream. It's a great demo.
It really was cool. Yeah. One last comment, and then I'll get to other people's questions.
Yes, sir.
His finger and his tooth. I remember about 25 years ago, they had an exhibit on the popes down at the Houston Museum of Natural Science. And they called them reliquaries. I think they had popes, pieces of their skull, fingers, all. So it's it was kind of a common thing back in the day. So anyway, that kind of
no, you're right. I totally didn't put two and two together. I was raised as a Catholic when I was a kid. They talked about the relics of the saints, Saint Peter, Saint this, you name it, and there was many of them, and that's similar to what we're talking about here with Galileo.
Right. Okay. I'm gonna shut up and get to other people here. Linda Jones asked for the internet web address for the video lessons on Galileo that you mentioned in the presentation. Glenn Lubens actually posted something. Linda, have you had a chance to click on that link and confirm that got you got you where you wanted to go? Are you there, Linda? Okay. Well, Linda may be still on mute, but anyway, Bill, the website posted was www.learn25.com/product/Galileo. Is that the website?
That sounds familiar. Yeah, that's either perfect or close.
All right. Well, if you're interested, please try that.
It's 12 hours of video.
Oh, okay. Fantastic. Alex Wisey, I didn't expect to see his actual bones. Yes.
Right. Me neither.
Yeah. Heather, it's a fantastic presentation. Basani says, this is my first time here. It's a fantastic presentation. Wonderful presentation via Linda. Chris Shumate, thank you, Bill. Thank you for your presentation. My granddaughter and I enjoyed it. That was from Crystal. Michael Nelson, very interesting presentation. I've also been a fan of Galileo since I was a kid. Played him in a play of famous people when I was in 4th grade.
All right.
So that's good. Let's see. Heather asks, David Scott did the feather and hammer test on the moon during Apollo 15.
Oh, okay.
And video is indeed on YouTube. So that is good to know. Thank you for that information. That's all we had in the chat. If anybody has any questions that they'd like to ask Bill before I wrap up with some announcements, please come off of mute and ask your question.
I apologize for talking so fast. I'm told that I do that sometimes, but there's so much to say. And again, that was just the highlights of the museum. There's a lot more in the museum.
Yeah, no, I mean, we recorded it too, so people can always go back and check the recording if they'd like.
Okay.
Rich, thanks for the presentation. He was at the museum almost 30 years ago, and it has more relics and videos
Oh,
it says it's fantastic. Ken Fountain says, thank you for the presentation. With that, I'm going to assume everybody has had an opportunity to ask what they'd like. So, with that, Bill, if you would come off of your share.
oh,
I will go ahead and just
stop
share.
share.
Yeah, there
Okay.
you go. Perfect. And I'm just going to wrap up quickly, folks, and just give you some information for the club. So thanks again, Bill. That was fantastic. Announcements. We have special interest group meetings in August. Here are the dates and times. They're all on Wednesday, all at 7:30. The visual SIGs next Wednesday, Smart Telescope, astrophotography, and then I don't know about the data and science SIG. They had their meeting last night, so their next one will be in September. Matt Borlagi sent out a email that had the meeting details in it, so you can get the links to the website to the Zoom meeting off of the website. And then finally, tomorrow we have our general meeting. It's going to be entitled Exploring with the James Webb Space Telescope. It's a Whole New Universe. And this will be by Larry Mitchell. Again, one of the wonderful speakers in the club. Larry has done some wonderful presentations on William Herschel. So I hope you're all able to make it out there. There is free pizza at 5:30 if you go in person, and the logistics and address can be found on the website. We do ask that you RSVP so that we have pizza available for everybody. And then if not, you can join via Zoom, and the meeting will start at 6 o'clock. So with that, that's the announcements that I had.